Okay, so today we're going to start Chapter 7 involving proportions and ratios. Again, this entire chapter really is going to deal with the concept of proportions for the most part. So the key is to make sure you understand this material in here in this video. If you don't, you need to make sure you ask questions in class. Otherwise, like I said, this entire chapter will be kind of confusing for you. Okay. So a ratio. A ratio is just a comparison of two different quantities that you're using division. A lot of different ways you can say it. Generally, you express it verbally as the ratio of A to B. So you can either say that written as A to B like that, A colon B, or A divided by B as a fraction. So it can look like that also, A over B. So for the most part, you generally see the ratios written ultimately in this fraction form. You may see it initially in the colon form, A to B like that, but ultimately you're going to write them as a fraction, reduce them as possible, and use them to solve problems. So for example, a baseball player's batting average is the ratio of the number of hits to the number of at-bats, not including walks. So if a player has 521 at-bats and 181 hits, what is his average? So again, the batting average is equal to the ratio of number of hits to number of at-bats. So the number of hits is 181. Number of bats is 521. So we don't want to leave that as a fraction. We're talking about baseball batting averages. Baseball batting averages are always this decimal form where they use three numbers after the decimal. When you divide that out with your calculator, you're going to get 0.347. It's a pretty awesome batting average, actually. So that's one way to use ratios. You use ratios all the time in baseball. You can see them as well in almost like football as well when they talk about completion percentages for a quarterback, stuff like that. Now another thing you're going to see a lot, especially on SATs, you'll see a couple questions similar to this, where they use a concept called extended ratios or group ratios. This is where we're now comparing three or more quantities. So for example, A to B to C. Comparing the ratio of three different quantities, A, B, and C. Now, you can't write all three of them as a single fraction. That would not really work out too well. Instead, what you're going to do is you're going to assume each one is almost like a quantity of 1 and add them together and compare each individual piece to that total sum of all of them. It'll make a little more sense in this example. So the ratio that measures the angles in a triangle is 3 to 4 to 5. We want to find the measures of the angles. So if I were to draw a triangle, and I may label our angles as 3, 4, and 5 degrees each. That would be the correct ratio, 3 to 4 to 5. The problem is, we know the angles of a triangle have to add up to 180. 3 plus 4 plus 5 is not 180. However, if I make this 3x, 4x, and 5x, we now have the ratio of the angles of a triangle still being 3 to 4 to 5. But now I can solve for this unknown x quantity to figure out what the actual measurements are really going to be. So I can say 3x plus 4x plus 5x equals 180. So when I combine like terms, 3 plus 4 is 7, plus 5 is 12. So 12x equals 180. Divide by 12, x equals 15. Now we're not done because the word problem says find the measures of the angles. So I need to plug 15 back into the problem. 3 times 15 is 45 degrees. 4 times 15 is 60 degrees. And 5 times 15 is 75 degrees. That is what the problem is looking for. They want you to find the measures of the angles of this triangle. So once you solve for x for these angle problems and these group extended ratios, you need to plug them back into the original. We can use the same concept with measures of the angles of triangles or any other polygon, quite honestly, to deal with as well the concept of perimeter. So the ratio of the measure of the three sides of a triangle is 9 to 7 to 5. We're told its perimeter is 191.1 inches. We're going to find the measure of each side. So again, it is helpful to draw our triangle. So 9, 7, and 5 would all be the correct side lengths for the correct ratio. The problem is they're not the correct side lengths for the correct perimeter. They don't add to be 191.1. So like with the angles, we'll make this 9x, 7x, and 5x. So 9x plus 7x plus 5x perimeter must add to be 191.1. Again, the angles always add to 180. The sides, when they give you perimeter, has to add to some number they tell you. Or there has to be something in the problem to be able to work with from there. When I combine like terms, I get 21x equals 191.1. When I divide both sides by 21, I actually get a nice decimal. X equals 9.1. And again, like with the angles, I'm not looking for just x, because x is not the side length. The side length is plugging x back into 9x, 7x, and 5x. So 9 times 9.1 is 81.9 inches. 7 times 9.1 equals 63.7 inches. And finally, 5 times 9.1 is 45.5 inches. That's our correct answer. The key also is with the sides, since I give you units, you must give me units back. So if I tell you the units are inches, meters, kilometers, centimeters, millimeters, whatever, you need to give me units back in your final answer. Okay, so I want you to give these two extended ratio problems a try on your own. So go ahead and pause the video while you work them out using what we just talked about, and I'll provide the answer for you in just a second. Okay, so you should have found for your answers for number 1, your angles are 18 degrees, 54 degrees, 108 degrees. For number 2, we don't need to find all the sides, we just want the length of the longest side. So that would be the one using the ratio of 3. That's why it's 168 inches. Now, a proportion. And this is what we're going to spend most of our time in this chapter solving. Proportions are an equation of two equal ratios. So we have two equal fractions. To solve these, you have to do what we call cross multiplying. So we would multiply 8 times the D, so AD, equals the B times the C. AD equals BC. Generally, somewhere in there would be a variable. So once we have our equation now, our products equal to each other, we're going to rearrange the equation to get the variable on the one side, the constants on the other side. The exact same way we would solve really any other problem. So we have this problem. So we want to solve this proportion. 5 over 9 equals 7x minus 1 over 36. The first thing you want to take a look at is, can you reduce this fraction right here, 5 over 9? And the answer is no. 5 and 9 have nothing in common, so that's as far as it goes. There are some other ways to go ahead and solve and reduce these fractions. I'm not going to go into the different tricks. If you do remember other ways to reduce fractions correctly, besides just reducing an individual fraction like that, go for it. The one thing I'll say is you cannot cross-reduce. That's if you're cross-multiplying. I'm sorry, if you're multiplying two fractions. If we're cross-multiplying, you can't cross-reduce. So cross-multiplying, 9 times 7 is 63x. 9 times negative 1 is negative 9. Equals 5 times 36 is 180. So in order to solve, we have to add 9 to both sides. So 63x equals 189. We then divide by the 63, and x equals 3. It doesn't have to be a whole number. It doesn't have to be positive either. If you get decimals, you get negatives, totally fine. So we take a look at this one, same concept. We can't reduce the fraction 4 over 11, so we need to go ahead and cross multiply. 11 times 20 is 220. And then 4 times 8y is 32y. 4 times negative 1 is negative 4. So we want to add 4 to both sides. So we get 224 equals 32y. We divide both sides by 32. Turns out y equals 7. Again, nice whole number. The key is, again, this whole cross-multiplying concept, and making sure you distribute the 4 to each one of these terms. In the previous round, distribute the 9 to each one of those terms. So one more together. So negative 5/8 equals 17 over 5z plus 4. Again, can't reduce that fraction, so we go ahead and cross-multiply. 8 times 17 is 136. Negative 5 times 5z is negative 25z. Negative 5 times positive 4 is negative 20. We should add 20 to both sides. 156 equals a negative 25z. We divide both sides, and negative 25 does not go into 156 nicely. It's not an awful fraction. You'll find the negative 6.24 is your value for z. Again, whenever you're giving me a decimal, make sure you always round properly. If there's more than 3 digits after the decimal point, you need to round that third digit up if it can, or you just cut it off. Okay, so I want you to go ahead and cross-multiply these two fractions together to get your answers. Whatever you get for x, that's fine. Just make sure, if you want to check your work, go right ahead. Feel free to reduce fractions if you can. So pause the video while you work that out. Okay, so you should be finding your answers are... Oops, well, the answers weren't there, so let me just pause and give you your answers. Okay, so you should find the first one your answers would be x equals 7, second one x equals -10. Alright, so that's it for 7.1, so I'll see you next time we talk about 7.2.